as I said last month during the second session of the time zone upgrade process, I wanted to show some demo today. So let's see how it works. I want to show the manual process of upgrading the time zone file, so the old one using DBMS DST. I may show the script-based upgrade next month. So I want to go using DBMS DST because first the script-based upgrade actually uses the same package behind the scene, just make certain things automatic. However, if we do certain things manually, we get better visibility in what happens. So it's kind of more interesting to demo. If you just run scripts, it's not that interesting, right? So I would like to show you some playing a bit with this upgrade. So, okay, let me share my screen. Okay, I hope you can now see my SQL Developer window. And I have prepared a PDB called PDB TZ that we will upgrade where we can show something. And this is a quite nice feature of CDB. You can just drop this PDB and recreate it again from a template PDB2 that I have used, so that I have user with and table spaces that I need for the test. It's quite a nice feature compared to the traditional non-CDB database where you have to copy the files to restore your testing environment. So let's connect to this PDB as a test user. You can see here we are a TZ_test user, and this PDB uses the time zone file version 32. This is the default file that comes with Oracle 19.3. And this is what was originally in my installation. And this is also what you get when you create PDBs from the seed, because the seed database uses this original version that comes with the database. However, I have installed a patch which gives me the version 34 available. This was released, I think, last year, actually. And this file contains 2019 changes. So let's see, maybe let me first share my browser. And we can check that there was a certain change in how Brazil actually handles its daylight saving time rules. This, as you can see, is a quite cryptic. This comes from the YANA page, because you don't have this descriptions in Oracle documentation. You just have a list of time zones that were changed and which year actually is affected by the change. However, the actual change is not really documented. So if we want to see the original changes between or detailed changes between time zone file versions, we can first look at the node. Okay, let me. Okay, so this is the central node. I think I have shown it in one of the previous sessions. Like so, the doc ID 412160.1, which documents some of the time zone file related changes. And here we have a list of patches, and this list will tell us that actually the DST version 32, so the one that I have currently in my PDB, corresponds to the time zone data version E from 2018. I talked about this versioning in the previous session. We want to upgrade to version 34. So this is the patch that I have installed, right? This is the patch number for version 34, which is the most current one. And it actually has the version B of changes from 2019. And if we now compare the information, actually this should be version E, but it's more or less okay. Let's not open it. Okay. I don't know why it doesn't want to show in my browser currently, but so let's just go with version E. There is no difference here between E and G. So the Brazil rule. Previously, Brazil would switch in November, on the first Sunday of November, to daylight saving time. Why November? Because Brazil is on the southern hemisphere, so summer is actually starts, let's say, in what we know as autumn in northern hemisphere. So daylight saving time changes in November. However, if we look at the time zone rules that correspond to the newest, so the version 34 of Oracle time zone file, we will see that we only have now 2018 switching, and there are no further information for Brazil as far as DST is concerned. This is because in 2019 Brazil decided to give up on DST and is not going to switch to DST, at least according to current plans. So all these rules that were previously present for like switching back to the standard time irregularly, because the switch back actually was dependent on whether the Sunday was a Carnival Sunday or not. So there were some years where the change was actually 1 week later, right? So first Sunday on or after 22nd, and not as usual on the first Sunday on 15 or later, right? So there were a lot of rules, and the rule to switch to the daylight saving time was max, so it's what was not bounded. So more or less it was a regular change in November, first Sunday of November. Now we don't have it, right? So there is an example of there are more time zones that changed between these two versions of the time zone file, but I have just selected one so that I can show some changes. And here, so the time zone description from Jana here describes the Brazil rule. However, this is not a time zone. The actual time zone that I have selected for tests, right, will be America Sao Paulo, which since 1965 actually follows this Brazil rule. Earlier, there were some specific rules that were maybe not the same as the rest of the Brazil. However, since 1965, Sao Paulo simply follows the rules that are described earlier here. Right. So this is a bit cryptic. If you want to understand it better, there is a file on the IANA on the IANA website that describes the actual structure of the time zone file, the text description that gets compiled into binary files. I have just shown you that there is this difference here that since 2019, Brazil does not switch into the DST. So let's do some tests with this time zone. So I'm just creating 4 tables just to compare how the upgrade process behaves for different content of time zone, timestamp with time zone column. The structure of all 3 tables is actually the same, very simple. Actually, the only column that is interesting is this TSTZ column. This is just an ID, which actually I don't use in the test. So I have put some Europe, UTC, Los Angeles. These are actually timestamps which are not affected by this time zone file upgrade that we show here, because there were no changes to like European Union rules or US rules between 2018 and 2020. I selected some timestamps from 2020. Of course, UTC has no rules. It's just standard time, so there were no changes here as well. So the content is similar for the non-Brazilian timestamps. They are just there as decoration, I would say. The more interesting thing is what we have in those tables as far as Sao Paulo is concerned, right? Here we have a timestamp in this year from December, noon. December is daylight saving time according to old rules, right? Because as I have shown you, the changes on the first Sunday of November. Previously, there was change to daylight saving time. Now, since 2019, there is no such change. So I have in this table, I have 1 row, which is just in sometime in December. So according to the current version of the file, version 32, which corresponds to IANA files from 2018, it is daylight saving time. The second one is 20th of February, and I have selected this. Sorry, I think I'm actually not showing you the right screen. I just realized. Okay. So these are the tables that I'm talking about. So TSTZ timestamp column, and this timestamps Europe, Los Angeles, UTC. They are just decoration. The one that, because they are not really affected by this particular time zone version change from version 32 to 34. However, Sao Paulo, as I have shown you, is affected, right? So this is December, daylight saving time. Here we have February 20th. February 20th is actually 21st is the date on which, according to version 32 of the file, so still with daylight saving time rules active for 2020, this time is ambiguous because at midnight on 21st of February, there would be a change from summertime back to winter time. So from daylight saving time to standard time. So the clocks go back 1 hour from midnight to 11 p.m. on the previous day, which is 20th of February. So I have selected some time in the middle of this period where we know that this time exists twice if there is daylight saving time still active. Because at midnight we go back and we repeat this 1 hour from 11 p.m. to midnight. So first hour is still in daylight saving time, and then we repeat it in the standard time. This is again still according to version 32 of the time zone file, because in version 34, which corresponds to new rules, there is no daylight saving time anymore. So this time is no longer ambiguous. However, in the older version, it's still ambiguous. In the third table, this Sao Paulo timestamp is some date in June, which means it's standard time. Simply, it's not affected by daylight saving time. And the table 4 does not have Sao Paulo timestamp at all. So these are some test tables with test timestamps. Let's just create them. Okay, everything created correctly, right? We can check the first table, for example, right? Sao Paulo. I have talked about the storage format for timestamps in October session, so you can view it again. Here we have 2020, December 8th, and this is offset 1, so it's not actually 3 p.m., it's actually 2 p.m., so it's 14. We remember that in this format there is a 1 added to the value. So this is 14, so 2 p.m. We see 12 because in summertime there is a 2 hours difference, or was actually, according to old rules, there was a 2 hours difference during DST. During standard time, the difference is 3 hours. And similarly, we have here, we see here it's actually 21st, and it's actually 2 in the morning, right, in UTC time. We remember there is a UTC time actually stored here, right, and the time zone information at the end that actually dictates how it is converted into local time for display. In standard time, we see here it's the 8th, it's 16, so -1, so it's actually 15, so it's 3 p.m. And 3 hours difference, as I said, in standard time to midnight. Okay, so we have this data. Now, let's assume, I will disconnect from this database. I will now do a small cheating. Let me share the window. I have a small script that I'm not going to show, where I actually do some trick to fool this PDB to think that it is now version 34 without any upgrade. right? So I have run the script. Let's go back to our test. Let's connect. Now we see this is version 34. It was not an upgrade. I'm just want to show what would happen without an upgrade, right? So I've just replaced the files, right? So we have now a version 34, even though we haven't changed anything in the database. So now if we look at this first table and its content, we still see 15 here, right? Which we know is it's actually 14, so it's 2 p.m. Now, this is version 34, so there is no daylight saving time in December, which means the offset is 3. So this 2 p.m. Becomes 11 a.m. So the local time, there was 12 here previously. Now we have 11. So without changing, the local time will be now off. We assume in this whole process that what users want to see after the upgrade are same local times. We don't want to keep the UTC time, because if an application actually wants to keep UTC time, then it should simply normalize the timestamps to UTC and store them in UTC, right? For example, in a timestamp column with an implicit UTC time zone maintained by the application. So generally for upgrades, if we have already made all the trouble to store the time zone information, we assume we want to keep the local time. So it's why a simple replacement of this would be problematic, right? Because we would just see a wrong local time off by an hour. So let's disconnect again. Let's restart our test. So I will switch to root. I will close this plugin database. I will drop it. And I will create it again from the template. So I will get an empty PDB again. Okay, now I will open it. Okay, let's connect again here. And let's recreate those tables. Okay, created. Now if we query this table, we see 12. Again, I have restarted the test. So we are back at version 32 of the file. So now let's do this correctly with the upgrade, right? So the first phase that we usually want to do is to check how many tables are actually affected, how many tables actually contain data that may require update when we change the time zone file version. So we use the DBMS DST package first to begin a prepare window. So we have two phases. One is preparation, and second is the actual upgrade. Preparation is like looking what is to be expected, right? So we prepare. Let me, by the way, first show you how the database DST related database properties looks like, right? So the upgrade state is none. This is normal version. The primary, so the production version of the time zone file is 32, and there is no secondary version because we are not doing any upgrade yet. So let's start a preparation window. Okay, we have started the preparation window. Now let's look at the properties again. And we see that we are in the prepare state, and the secondary, so this newer version was loaded into SGA so that database can do the actual comparison of the values for the old and the new version of the time zone file. Now we can execute another procedure in the DBMS DST package, which is find affected tables. And we can also ask to log particular rows that may have some errors. I have discussed these errors in the previous session. So this overlap issue or non-existent time. Normally, we actually say that you can kind of ignore them probably and just let Oracle handle them by default, because default behavior is usually reasonable and correct. However, if you really want to make sure that everything is fine, you can log those errors. So let's call this procedure. It looks now through the database and looks for tables that are affected, right? And we can now check affected tables. We see there is one affected timestamp with DST. So this was in the first table, in our first table, test table. There is also one in our second table. We have also the column name. And here there is one error, because you remember in the test, I have prepared one row that is exactly in this duplicate time, right? So this was found, this problem was found. You can see that table 3 and table 4 are not listed, because table 4 does not have any Brazilian timestamps at all, or from other time zones that changed between version 32 and 34 of the time zone file. And the timestamp at the third table is also not present, because the timestamp there was in standard time, so was not affected by the change or was not affected by giving up the DST change in 2019, because it was already standard time. So there is no change whether DST is now observed or not. In the error table, right, we actually see this one row. There is a row ID of it. There is the error number, which corresponds to the duplicate time, right? And we can actually copy this row ID, and and if we query it here, we see our problematic timestamp from the second table that is duplicate, right? So, okay, so now we know what is to be expected, right? How many tables actually have any timestamps that may need modification during the upgrade phase. So let's finish the prepare phase, right? Now the database properties are back to normal, right? We can always restart the prepare phase. There is the file, the new file has been unloaded. There is also an interesting view, DBA TSTZ tables, that shows us all tables in the database that actually have any timestamp with time zone column, so which are potentially affected by any time zone file change. So we see here there are some Apex tables, there are some data dictionary tables, quite a number of various system tables, VMSys as well is actually a data dictionary, but not sys, and our 4 tables are all listed here as well. There is no upgrading process, so the upgrade in progress. So the upgrade in progress column shows no for all those tables. Okay, so now let's go to the actual upgrade, right? So first we will run an just let me make sure we have server output on, because then we get some interesting output from the procedure as well. Okay, this I have already executed, I think. Okay, now let's start the begin upgrade. Actually, so the parameters are the new version of the file, because I may have installed multiple patches with versions 33, 34, and in the future further versions. So I can select here into which version I actually want to upgrade. So I want to upgrade to the version 34, which I actually have, right? I can look in the, I know which patches I have installed. And there are 2 parameters that tell me if there are any errors of this overlap time or non-existing time during upgrade of the timestamps in the sys schema, whether they should stop the upgrade or not. By default, we want Oracle to handle those errors and do some best guess update of those timestamps. So we just leave these parameters at their default values. We can just skip them. I have shown them here for like documentation purposes. If I try to start this process here now, I will actually get an error, because to start an upgrade mode, I also need the database to be in the upgrade mode, because I'm going to modify the data dictionary, and we don't want data dictionary to be modified like globally in the standard mode. So I have to close the PDB. And open it with the upgrade option. Okay. Now let's start again. This time, this was successful. So let's look at the state. The state is upgrade, right? We have the production is now 34 already. The secondary file is 32. So we have already switched the version to the new one. And if there were any timestamps for Sao Paulo affected in sys tables, those timestamps would already be updated. I don't have any such timestamps there, so there was really no update. However, if there were some scheduler jobs scheduled in this for this time zone, they would have to be updated so that local time is still valid after the change. If we actually let's disconnect and connect again here, we cannot connect because of the restricted session privilege. Unfortunately, let me check. Let me try this query as system here. I just need a schema. So this is interesting, right? We get an error here, function not allowed until the database is restarted, right? So there is a requirement that directly after the begin upgrade, you actually have to restart the database and open it in normal mode. Until then, you cannot query any timestamp with time zone columns. So if I try to query this table, this column, which is timestamp with time zone, it won't succeed. So I have again to close the PDB and open it. I can open it in normal mode now. Right. The state is still the same. Upgrade state with the same versions. However, if I can actually connect here now, because okay, there is some problem here with, however, I'm connected, right? And I can query the timestamps here. And here you will see an interesting thing. We see actually, even though we haven't updated the user columns yet, right? Already the new file is active, right? So the primary version is actually 34. So there is no DST anymore. So we would expect at this time for this timestamp to show the 11, the one that I have shown in this cheating test, right? Where I cheated and changed the version without an update. Here, during the upgrade phase, it is already correct, right? But we can also see one interesting thing here. When we look at the dump, the data type here has changed from 181 to 188. This is still timestamp with time zone, except that it is now in a special structured format, which by itself is not maybe very interesting. However, it signifies or signals that we don't have the direct content of the column, which would be this 181 and this format that I have explained in October, the so-called array format for the timestamp. We have here the structured format, which is used internally by Oracle database when evaluating expressions, right? And so we see that the format is different here. We don't see 120, 120. We actually see this is a little endian 2-byte value, which also is 2020. However, it's no longer this offset 100 century and offset 100 year that we had in the other format. And also the hour here is actually no longer offset 1. So this is because Oracle database behind the scene automatically adds, during this upgrade phase, automatically adds a conversion function that converts the stored value to the current primary time zone version. So it corrects the value on the fly because the table has not been yet upgraded. We can check it here. If we look at this TSTZ tables, right, view that I have shown, we will see that at this stage, all user tables, so Apex is treated as user tables, right? Some of the data dictionary, which is not sys, are not yet upgraded. So the upgrade is in progress. Only sys tables have been already marked as converted, so they are no longer to be converted. And this is the same here with with our test tables. They are to be converted. This behavior can be actually changed with a parameter that you see here. So its default value is true. If I change this parameter at the session value, at the session level, DST upgrade insert conversion to false, and query this table again, the first test table again, I will see 11 here, and I will see the type 181 back. So we are back looking at the column values directly. There is no function added. So the type was not changed from the array on disk format to the structured evaluation format. So there is no function here. This parameter has been added. So we recommend that this parameter is left at its default value of true, so that you see the correct values for the time zone file that is active, and that you have also consistency between tables that have already been upgraded and that haven't yet been upgraded, because this conversion operator will only be added to tables that have not yet been converted. So those that have this upgrade in progress column value set to yes, right? So only for those there will be this extra conversion function added on the fly. We have this parameter for special cases, because if there is a function added implicitly to a column value, then obviously any index that is defined on this column will no longer be used by the optimizer, because optimizer does not use standard indexes if there are functions on the column. You would need a functional index defined on this function that is added, which we don't have. We just have standard indexes. So if you know that your column will not be updated with those affected timestamps from time zones that are affected by the current upgrade of the time zone file, and you won't select those values from those timestamps, then you can set this parameter to false, so that your query is faster and can use index access. However, generally, except for these cases, you should normally keep it as true, and actually possibly keep the upgrade window as small as possible, and not run production while the upgrade is running. But somehow you have no choice, right? You have a 24/7 database, and you have to, you cannot, and you have a lot of affected columns, and this is then you don't have the time to actually wait until all tables are upgraded before you give the database back to production. So we have already this short window when the begin upgrade procedure runs, where you actually have to be in upgrade mode, so the database is not accessible. Once the data dictionary is upgraded, which usually is not affected much, there are some steps described how you can remove some of the data that may be affected, but it's not that critical, like some history of statistics and so on and so on. So some historical data you can remove, so that the upgrade window is as fast as possible. And then user tables, which may be huge and may need a lot of time to upgrade, you can actually run theoretically during production, even though it's not recommended, of course, because these functions have to be added, and there is this effect on the indexes and so on and so on. However, the functionality is there. So once we have switched to upgrade mode and switched to the new file, as long as the parameters at its default true value, you actually already see the correct values, even if they were physically not changed on the disk. So okay, so let's actually now try to upgrade the database, right? So once we have opened the upgrade window, we can actually upgrade the database. There are three procedures that we can use for it. One is upgrade database, second is upgrade schemas, and third one is upgrade tables, right? So generally you would want to upgrade the whole database at once. However, if for some reasons you want to control precisely what tables are to be converted, then you can use lower level functions. So we run upgrade database. There is one out parameter that returns the number of failures, so number of tables that could not be upgraded successfully. Then there is a parameter upgrade data, which is interesting. It controls whether we actually upgrade the data. So there is a theoretical possibility that we don't want to the upgrade to keep the local times, but we actually want it to keep UTC times for some reasons. It's seldom you would, as I said, in such cases you would normally have some timestamps normalized to UTC if you want to keep to UTC. However, if so for some reasons you don't want to touch this data and you just want to leave it as is, you can pass this parameter as false, in which case the upgrade database will only mark the tables as converted, but won't actually touch anything in those tables. So the standard value is true, we want to upgrade. Parallel, whether this upgrade uses parallel option, default value false. Continue after errors. So do you want to, if there is a problem with one table, do you want to continue with other tables, or do you want to fail, right? So stop the procedure. Default value is we continue. And then we can log errors. Again, recommended value is false. Let Oracle actually do the thing. So we can log the errors in this standard table, or pass our own table if we want, for example, to put it in some user table space, because this one is predefined in systems or sysocs or system table space. So there may be not enough place there. So you may want to actually put it into another table space that you want to drop later, or whatever. And here the default value is, again, ignore errors. For testing purposes, I have set it to true. So we will actually fail on the second table, which has this one row with a problem, right? Just to show the effect. Non-existing time, we don't have such error, so it doesn't really matter what's the value of this parameter. Log triggers, I mentioned this table previously. It stores the names of the triggers that could not be automatically enabled, because they have to be disabled before updates to tables. We don't have any triggers on our user table, so this is not really relevant. So let's start. Let's start this procedure. Okay, so PLSQL procedure successfully completed. So actually, if we look at how the tables look like, right, we will see that there is still one table which is in upgrade progress because it failed, right? If I try to end upgrade now, I won't be successful, right? Ending an upgrade window failed because, again, there is still one table that is not upgraded. As long as this table is not upgraded, we are not able to actually end the upgrade process. So let's now try to upgrade just this table, right? Upgrade table, this particular table that is problematic, right? And this time I will say don't error on the overlap time, so it should now succeed. Okay, let's clear. Okay, PLSQL procedure successfully completed. And now I can hopefully end the upgrade. And if I look at the state of the database properties, we see upgrade state none. We are already at the version 34 of the secondary. The secondary time zone is 0, primary is 34. So this is one. This one is the production. Let's just reconnect in any case. Let's see what's in those tables, right? We see that a local time has been preserved, right? In the second table, it's also preserved, right? So the Oracle handled the error properly, and that two other, the third and the fourth are not really relevant, as we remember, because there were no affected timestamps here. So there is this one in June, which was not really affected, and in the fourth table there were no Sao Paulo rows at all. Okay, I just wondered why I don't have only one row here, and now I noticed I made a mistake here and I have put it into the wrong table. That's why it won't show. Anyway, okay, so this was the process. I must admit there is one problem that I noticed that I don't quite yet understand. I have to double check it. I haven't found the reason yet, because I said during this upgrade, this correction upgrade table, I said actually upgrade data false. And it still upgraded the data because it shows the local time correctly as 12. And I don't quite know why. And I will investigate this and let you know in January, in next session, why there was this problem with. Oh, sorry, I know why the problem was there. Is actually this. Okay, so I just thought that I checked table 1. I thought that this will be affected, but then I just recalled that actually the error was in table 2. So this is this timestamp that was not really physically upgraded, and it still gave us the right local time, which is fine. So this value was not really updated, but could be that it wouldn't be updated anyway. So this is fine. So there is no error here. I should have simply shown this on another table that it would be then clearer that if this parameter is set to false, then there is actually no upgrade to the table. So I just shown it on the wrong timestamp. Okay, so at least this is clear. We are already, it's already past the hour. So any questions? As usually, you can ask them also through the Ask Tom interface to office hours, or you can also go through the recording and try to understand it again and ask questions next month if you prefer. Okay, let me stop sharing. Okay. I see no questions today. Thanks for wishes. Same to you. And let's continue in January. I plan to actually show the script-based upgrade process as well, which is much simpler. It won't show all this peculiarities, I guess. So I hope anybody who will watch the recording will find it interesting as well. Again, please ask questions either in following office hours next year or through the Ask Tom interface, where I can either answer the questions directly by email, or I will talk about it during the next office hours. Okay, so thanks for today and goodbye.